Okay everyone, let's begin. So, if you've opened your notebook up, you'll notice we're recapping a skill that we learned in semester 1, and that's because it's foundational to what we're going to go through today. Today's a really meaty lesson. It's one of my favourite lessons. It's lots of fun. Nonetheless, we're just going to go over this together. And you're invited to, you don't have to, but there are some questions that you can do listed on the checklist. We won't pause to give you time to go into them. We'll just move straight on from here into the lesson today. And you can see it's going to take place over a number of pages. We're going to work through it together and we'll develop an understanding of the essence of calculus today. So let's have a look up here. We have a function of x, all right, a function with regards to x, and it's a quadratic. The leading power is a 2. And we're asked first to find f of 1. That means what's the value of the function when x is 1? So we're going to take that number 1 and we plug it into this function here. We're going to have 1 squared plus 2 times 1 plus 3. 1 plus 2 plus 3. 6. Alright, so f of 1 would be 6. Alright, next we're going to have f of h. Now just following what we were doing, if we're finding f of h, that means we're going to put h everywhere there's an x. So that would just be h squared plus 2h plus 3. That's the simplest we can write that. We cannot simplify that in any way. Okay, so hopefully we're okay with that. Then we have these composite functions. In here I've got x plus 2. So we've got, here's f of x, I want to find f of x plus 2. That means I'm going to put x plus 2 everywhere there's an x in this function. So x plus 2, we're going to put it there where the x squared is. That's going to be x plus 2 squared. Okay? Then we have plus 2 lots of x plus 2. And then we have this plus 3 hanging out. There's no substitution going on there, it just stays as plus 3. Alright, what we'll do now is we're going to expand all of that and collect like terms, because that's going to be a skill that pops up for us as well. I'll just write the perfect square formula up here again. Alright, so we did cover that in term 3 as well as in semester 1. So we're going to expand this using the perfect square rule. If this is a skill you need to practice, let me know. I can provide plenty of resources, but I'm going to do it in one step. Okay? This expands to x squared plus 2 lots of x times 2 plus 2 squared. A squared plus 2ab plus b squared. Alright, that's the perfect square expansion. To expand this second term, we're just going to distribute the 2. So we're going to have 2x plus 4, and then we have plus 3 hanging out there. All we'll do next is simplify. 2 times x times 2 is 4x. Alright, we've simplified all of the terms. And now we can add together like terms. So like terms have the same power of x, right? We only have one x squared term, so that's going to be at the front. We've got 4x here and plus 2x here. So that would be plus 6x. And then we have 4 plus 4 plus 3. So that'll be plus 11. Okay, so the main skill I want to emphasize here is just the substitution of x plus 2, right? We're putting that everywhere there's an x. So that's what you need to be able to see, is the link there, all right? The expansion is going to be something that pops up throughout the exercise as we're doing it. Okay, f of x plus h. This is going to be pretty similar, isn't it? Now, rather than putting x plus 2 everywhere there's an x, we're going to put x plus h everywhere there is an x. So we'll have x plus h squared, all right, putting it there. And then we'll have plus 2 lots of x plus h, putting it there. And then we will have plus 3. All right, there's no x in this one, so the 3 is just hanging out by itself. Okay, let's expand this and collect like terms. So this is going to be x squared plus 2xh plus h squared. This will be 2x plus 2h, and that's just plus 3. And we don't have any like terms along there. All right, this one's x squared, this one's xh, this one's h squared, this one's x, this one's h, this one's a number. None of them are like terms. None of them have the same value of x or h. Very good. Okay, so again, like the main thing we're interested at this point in time is just the substitution. That you understand, if I'm finding f of x plus h, that means I'm taking that and plugging it where the x is. Okay? All right, so let's move on then. Let's turn the page and we're going to find this instantaneous slope at a given point. I'll rub this out. And so we're starting with the function y equals x squared. I've got a graph of it for you. Here's what it looks like. This is the function y equals x squared. Now let's just talk about a few things we discussed yesterday. We had constant rate of change. We had average rate of change. And we had instantaneous. Instantaneous rate of change. Okay, constant rate of change, we know that occurs if we have a straight line. All right, a straight line means it's always increasing by the same amount. Average rate of change is the rate of change that occurs over an interval, and instantaneous rate of change means occurring at a single point in time. Okay, remember your average speed camera safety zone from Kiki to Canalpin, and remember your instantaneous rate of change, that's the policeman hiding behind the bend, catching you at one point in time. Okay. So we've got the graph here. Draw a chord over the interval. 2 is less than x is less than 3. So you're going to go to the function and we're going to go when x is 2, we'll draw a dot on the function there. And when x is 3, we'll draw a dot on the function there. Okay? And you're going to draw a line connecting those 2 points. A straight line connecting those 2 points. Alright, so it's not quite going to match up with the function. It's going to be out of it a little bit. We call this a chord, okay, because it cuts across the function. I might exaggerate it so you can see what I mean. If this is the function, this is what your line will look like. Okay, you're drawing a straight line. Hence, find the average rate of change. So we want to know the average rate of change. Remember, the average rate of change, the ARC, that just means the slope, doesn't it? It's y2 take y1 on x2 take x1. Now, we have 2 coordinates already. We've got x is 2, and we've got x is 3. All right. How might we find the y value? Just square it, don't we? Because the y value is equal to the x value squared. So if we have x is 2, then the y value would be 2 squared, which is 4. All right, and if we have x is 3, then the y value will be 3 squared, which is 9. Okay. Now let's find the average rate of change. y2 take y1 divided by x2 take x1. So that's our answer for part 1 there. Draw a chord and hence find the average rate of change. Now, for part part 2, this is what we touched on yesterday. It says, let us find the instantaneous rate of change by drawing a tangent at the point x is 2. So remember, a tangent, if you have a curve, a tangent is a line that's parallel to the curve. And if we find the slope of that line, that will tell us the slope at that point. Okay, that's a skill we did yesterday. We will skip over that one for now, okay, because we did that skill yesterday. So we're just making a recap. Here's average rate of change. Here would be instantaneous. One error with drawing our own tangents is they're all going to be a little bit different. It's not a very precise way of doing it. Fortunately, we do have a wicked algebraic method to do it. Let's turn the page. Okay. Now let us consider the point P. All right, so this is point P when x is 2 and y is 4. And you can see if we zoom in on it, the curve begins to resemble a straight line. So I've zoomed right in there on Desmos and I've captured that screenshot, and you can see that looks like a straight line. Okay, and so the analogy is like planet Earth. Okay, if you think of planet Earth, all right, apparently it's round, all right. But for us, it looks flat, right? You look out at the horizon, it looks like a straight line. If you zoom in enough on something that's curved, it will look flat, okay? So that's what's going on here. We've zoomed in on it. Now what we're going to do is we're going to consider, I'm going to rub this out for us. We're going to consider the chord P. So here's point P, which has an x coordinate of 2 and a y coordinate of 4. And we're going to consider M, and we're going to find the slope of the chord PM as we move M closer and closer and closer to P. All right? So I've got a number of coordinates that we've got there. We've got x is 2.1. So let's draw up this table and we'll go through it together. So we've got coordinates of M, x and y. So firstly I've said let M have an x coordinate of 2.1. So if M is 2.1, that means the y value is going to be 2.1 squared, right? And what's that, 4.01, is that right? 4.41. Thank you. Okay, so let's go to our table here. We've got x is 2.1, y is 4.41, and so then the slope of PM, the slope of chord PM will be y2 take y1, okay, 4.41 take 4 divided by x2 take x1. So what have we got? 0.41 divided by 0.1. Okay, next what we're going to do is we're going to move M even closer. So I'm zooming in even more, and I'm moving M closer such that the x coordinate of M is not 2.1, but it's 2.01. All right, it's 1/100th of the distance rather than 1/10 of the distance. Okay. So if my M value, if my x value is 2.01, then my y value will be 2.01 squared. Right.
0401.
Excellent. 4.041.
0401.
040. Okay, and so now y2 take y1. We'll have 4.0401. So we got 0.0401 divided by 0.01. 4.01. And one more just to emphasize, okay, we're moving it even closer such that it's 2.001. The y value will be 2.001 squared. 04001. Okay, so we're starting to notice a pattern. What's happening as we move m closer and closer and closer to p, what's happening to the slope of pm? It's getting closer and closer and closer to what number?
0.
4. It's getting closer and closer to 4. Yep. The distance between them is approaching 0, but we can see it's getting closer and closer and closer to 4. Okay. Make a conjecture about the slope at x equals 2 as point m gets closer and closer to p. What does a conjecture mean? It's like a mathematical guess, right? This is what we anticipate the result is. Well, we can see as this is getting closer and closer, this number's getting closer and closer and closer to 4. So our conjecture then is the slope at p, the instantaneous slope at p, instantaneous rate of change is 4. That's our conjecture. That's what we're going to guess based off of what we've observed here. Okay, I'm going to clear the table. Alright, so now to prove this conjecture, we're going to have the point P, which has an x coordinate 2, y coordinate 4, and we're going to have point M, we're going to zoom right in on it so it's even closer. And the x coordinate of point M is going to be 2 plus h as h is approaching 0. Alright, remember we did limits yesterday. H is almost 0. It's not quite 0, but it's so close to 0. Like these are, you can't see the difference between them. Zoomed in heaps. They are so close together. It has an x value of 2 plus h as h is approaching 0. Okay, the x value is 2 plus h. What's the y value? Okay, we see if the x value is, yep. If the x value is 2, the y value is 4. What if the x value is 2 plus h?
4 plus h.
You've got the right kind of thinking. If the x value is 2, the y value is, let's put it like this, 2 squared.
2 plus h squared.
Very good. 2 plus h squared. Okay, so this is where the function notation comes in. And so if we want to find the slope of this chord, okay, now it says go on to determine the y coordinate, we've done that, so we're at part 6 now. Determine the slope between p and m in this instance. Well, the slope is y2 take y1 divided by x2 take x1, right? So the slope of pm, y2 take y1 on x2 take x1. I'll write it up here to communicate it clearly. Here's y2, here's y1, here's x2, here's x1. So we have 2 plus h squared, take away 2 squared, divided by 2 plus h, take away 2. Okay, so we're going to expand this using the perfect square rule. This is going to be, I'll write it up again, I've rubbed it out before. So if we have 2 plus h squared, it's going to become 2 squared. Alright, a squared plus 2ab plus b squared. Then we have take away 2 squared is 4. And at the bottom here we have 2 plus h, take 2, the 2's will cancel, and we're just left with h. just simplifying, this is 4, this is 4h. H squared, take 4, all on top of h. 4 can cancel, we have 4 take away 4, so that will cancel. And so we're left with 4h plus h squared on top of h. This is quite similar to a question we did yesterday. We can simplify it, right? We've got h's at the top and h's at the bottom. This is technically what's going on. We're factorising the h. Okay, if you pull h out the front, that's what the expression would become. And then we have h at the top and at the bottom. Right, we've got h at the top and at the bottom as a product. It can cancel. We're left with 4 plus h. And what is h?
Approaching 0.
H is approaching 0, which means the slope is 4. Okay, just as we conjectured, that's what we thought it would be. All right. So on to the next page. All right, so we turn the page, we've got find the slope of the coordinates of P using the process outlined in step 5 and 6. Okay, so we did it right. I'm going to sketch the graph up here. We did it for the point at x is 2. All right, we're going to do it now for the, we're going to split up and we'll each do one, and then we're going to report back together to fill in this table. So we've got y equals x squared. We did it at x was 2 and the y value was 4, right? So let's fill in, let me draw up this table and I'll talk about how we're going to solve it together. So coordinates of P, and we've got x and y. Okay, these are easy to get. If we have x is 1, then the y value is 1 squared, 1. If we have x is 2, then the y value is 2 squared, 4. If we have x is 3, the y value is 3 squared, 9. And if we have x is 4, the y value is 4 squared, 16. Okay, so we've filled in the y values there. Okay, so that's the coordinates of point P. Then we have the coordinates of M, right? So I'll put here coordinates of P. Yep, so that lines up there. Coordinates of M. And we've got x and y. So if we have, so remember, what are we doing? We've got here point P. Let's go for the example we've got at the moment. X is 1, y is 1. And we've got M, excuse me, M, which has an x coordinate of 1 plus h as h approaches 0. We're putting it really close together. So if the x coordinate is 1 plus h, then the y coordinate is 1 plus h squared. Okay? Same here, if we have 2 plus h squared, 3 plus h, 3 plus h squared, 4 plus h, 4 plus h squared. Okay, so we filled that in. And then here we've got slope. Now I just want you to write a number in here because we're going to start to notice a pattern. Okay? So we'll just write the number in there. How do we calculate the slope? y2 take y1 divided by x2 take x1. Alright, so I'll do the first one for you and then we'll split them up. We've already done this one too. We already did that just before and we had a slope of 4. Alright, so we've already done it for 2. So for 1, we're going to have 1 plus h squared, y2 take away y1 divided by x2 take away x1. Okay? Simplify this using the perfect square rule. At the bottom, 1 take 1, it will will cancel. At the top, we've got 1 take 1, that will cancel. We factorise and cancel the h. H at the top and bottom, cancel. H is approaching 0, which means our answer is 2. Okay, so I'm going to pause there for a bit, and I reckon let's have a quick look up here, and this will be wicked. All right, so hopefully there we cracked out 8. So we're starting to notice here 2, 4, 6, 8. Here's the x value. Here's the slope at that point. Very interesting. So then what do we anticipate it being when x is 5? 10, 12, 14. How about if we just take some value x?
Is it 2x?
2x, very good. What we can see is it's just whatever the x value is, multiply it by 2. Excellent. Let's prove that this is the case. So from 8, what do you expect it to be there? Here's part 9. We expect the slope to be 2 times the x value. On to part 10. What we have now is we have point P that represents any x coordinate. It doesn't have a particular value. It could be located anywhere on the function. Any x value, the y value is x squared. Then we have point M, which is really, really, really close to it. In fact, so close that they're almost indistinguishable. And it has a coordinate of x plus h, as h is approaching 0, and a y value of x plus h squared. So this slope of PM then, let's do it here. y2 take y1 divided by x2 take x1. Alright, that's the slope of PM, where P is any coordinate on the function. So we'll have x squared plus 2xh plus h squared, and at the bottom we'll just have h. X squared will cancel. So we just have, I'll do it in a couple of steps this time, it's a bit more confusing. That's what we're left with. H is common, so we can factorise it. And cancel, because it's at the bottom and top. H is approaching 0. What are we left with? 2x. Gorgeous, right? Beautiful. Fantastic. What this is the slope function. That means we can know the slope on this function for any value of x. What's the slope when x is 1,000? 2,000. All right? So that's really cool. We've arrived at that. And then when we come back, we will put it into a formula and use the formula to solve some of these problems. So hopefully you felt reasonably okay. This is just an introduction to it. And then next lesson, we will use the formula to solve some of these problems. So good work. Enjoy your break.